So this is the outline of the presentation, as Antonio just told you. I'm going to tell you about access rights and how to access the MCS and the structure of the MCS and how you can upload uh, data to MCS and how to modify your device operations if you need to, and also how to use DShip. And at the end, there are some practical examples. And as Antonio already told you after the presentation of on Jupyter Hub from Stefan Pinken and David Wagner, I'm going to show you an example how to access files on MCS via SFTP. First of all, where you can find all this documentation is this address, mosaicdata.org. And that's a collection of all the information you need when you want to work on or work with your MOSAiC data. And if you have some problems, you don't know how to get information, then you have these two email addresses, support and O2A support. First, the access rights. Everyone who wants to access MCS or other systems to work with MOSAiC data needs an own personal MOSAiC user account. So that means that you shouldn't share your personal credentials with anyone. That means that you have to sign a MOSAiC data policy, and then you send that to Avi, and you get an email from e-account at avi.de, and there's just your credentials and login date is in that email. And there's also, as I mentioned, all is documented in the documentation under this get user account. At the end of presentation, I'm going to show you the pages where you can find information. So, and how you can access MOSAiC data on MCS on a MOSAiC central storage. You can find all information for accessing MOSAiC data on land, and one possibility is to access the data via SFTP. There are several possibilities, for example, FileZilla, SFTP Drive v2, or Cyberdruck. And what do you need to connect? First of all, you need the server, which is mosaic-data.org. Then you need your personal AVE account username. That's what you get from e-account. And then you need a password. That's also your personal password. And it's not the same password you had on board if you were on Polarstern. So you have on land, you have another password. And once connected to the MCS, you're in a folder called home, local, and username. But what we need, you have to go to easy, EHV, and platforms, and that's like platforms on Polarstern. And there you can find your raw data, readable for all. If you want to write data on platforms via ingest, you have to be edited a data provider for your devices and sensors. And if you need to update or change some files, you need to contact the data team at Avi if you're a data provider and want to update or modify data. So contact the data team by Avi. If you want to upload additional raw data or some analysis for your devices, then you have to use this ingest feature. On MCS, there's also workspace under this address, and there's read and write access for everybody. It's a new structure since November, and you might have to move some of your data into proper places, but you can still visualize your data, share your data, and also work in teams on workspace like it was on board as well. This is the structure of the workspace currently. I don't know if there are going to be some changes, further changes, but this is how it looks like now, and further changes are of course going to be uh, told you in beforehand. Another possibility to access the MCS is via Nextcloud. Uh, Platforms is download only, and the MOSAiC workspace upload and download. But this system is currently rather slow, so it is recommended to use SFTP if you have larger amounts of data. Then the ingest service, that's for uploading new data, or if you have lab analysis of MOSAiC samples, uh, then please do that via ingest services. But before you do that, you need to be sure that you are a data provider or editor in Sensor for your devices, and also that all devices and events are described in Sensor, so you don't have any device operations missing because you can't. They are not there if they are not in Sensor. And if you need to some lab analysis, uh, then there's also in the documentation the instructions how to do that first, and then you can um, upload your data on the proper place. If you need update device operations, then you have to do that via Pangea. They are published and updated via this system uh, beneath expeditions, and is there you need a register. If you have orchid, you can also use that to log in and submit your data, or you can also create an account. That's what I did, and it was really easy. Just fill in the form, and then you get an email. You have to verify this, and then you can submit your data. And there's also in the documentation there are guidelines how to do that. And there's this DShip portal. Uh, that's from sensors that are permanently installed on Polarstern. For example, temperature and humidity, weather data, position data, and you can access it freely via DMS at .avi at .de, and there's no login required. You can start your extraction under any username you want to, and then you can have it without login. And what is important to note is that you have to be patient if you have long extractions with high temperature resolution. Some of you might know that from Polarstern already that it can take a very long time, and then it's good if you leave an email address for notifications when it's ready. So, well, so this is the main page where you can. I hope you can see the page I want to show you. MOSAic-org. There's a collection of all the information you need. For example, here you can access the data documentation, and here on the left side find any topic you want to know, and there's every is documented. And if you don't have a MOSAiC user account, you also find this under this topic, how to get a MOSAiC user. As I said before, it's important that everyone has an own account. Don't share your credentials with anyone. Here's the guideline to get uh, the personal account for non-AVI members, and AVI members participate in different legs and so on. And also this topic, how to access MOSAiC data on land. You can find it step by step, what to do. For example, if you want to use SFTP. I can show this. So I use this SFTP2 drive that is also in the documentation. If you want to have a new drive, you push new. I show you that in my because I already have it. So this is the data I've entered. The name is MOSAiC-data. Remote host is mosaic-data.org. And then you have to use your MOSAiC username and your password. And remember, it's not the same password you had on board, the automatically generated password. So, and then you can try to connect, or I can try to connect. And if it won't work, I have people there, I hope, who can help me. Sometimes this takes a while. So this is my home local folder, but where I want to go is this one. And there you can find platforms and the workspace. Platforms look exactly like it was on board as well. And then you can find your devices, the platforms you have. And that's how the workspace looks right now. You can have in platforms process, for example, you can find the same things that are also on platforms. I can show you, this is quite easy, but as I told, it's quite slow and not for larger amounts of data, or maybe it's just my internet connection. Oh, okay. That's typical for a live stream, but it's quite easy. So you just have to uh, log in, and then you have platforms and workspace, and it looks like SFTP. It looks like it's the same. The structure is the same, almost the same. And this one's ingest services. If you need to upload or update some data, or you want to submit something, you just go to submission. And then you're in the folder. You see which platforms you have, or which uh, devices you have, where you are editor or data provider. For example, then you can drag and drop your files as it says here, and then when you're ready uploading your data, you just push this button, and then it's going to, then a request is sent that Avi is going to store and archive the files. And the next thing, the Pangea. I'm not that much into detail. As far as I know, there's going to be an own webinar for that. Um, Here on the bottom, you can find these teams. You can take expeditions. If you want to, you can also look for different research vessels. But now I'm going to MOSAiC. Here you can find the listing of all the legs, and further links if you want to have a closer look to something. And if you want something, so if you want to update your ship data or device operations, then you need to do that. I'll submit. Yes, here you need to log in. You can use your org ID, or as I told you before, you can also sign up as a new user. It's also a really quick thing for a couple of minutes, and then you are ready to submit. And there's also documentation that if you need to update or add some T-ship device operations for path legs. You can find the detailed information in the documentation. Each step what you need to do. And there are also further links, interesting links. You could have a and the D-ship. If you want to have some data from different vessels. Now we want to have something from just so data extraction. You choose the starting date, how end date and start date, what you want to have, how the temporal solution you want to have, and then you just go through these instructions. And then you can afterwards you can have your downloads by pushing this button. As I told you, you can use any username. You don't have to log in or something like that. You just choose anything, and then you have to know that what you choose, and then you can have it afterwards as well. You can get your extraction later on as well. And again, if you don't find in the documentation the information you need, you can contact support at mosaic-data.org or O2A-support at avi.de. And now I'm going to hand over to Stefan Pinkenel and David Wagner. And after that, I'm going to show you an example how to access the files on MCS via SFTP again. So we have a real practical example for that.
Yes, thank you, Heidi. Then I will take over. I hope you can see my screen soon. Yeah, my name is Stefan. I would like to show you how you can use our Jupyter Hub infrastructure to work with your data on the MOSAiC central storage here at AVI. And I would like to start with the same page that Heidi already showed you, because this is a nice starting page where all the links are put together. And here you can also find a link to the Jupyter Hub system, which I would like to show you first. I've already opened it. Again, Heidi already said, for everything that we show you here today, you need a personal user account. And for parts of it, you also need VPN access to the AVI network. This Jupyter Hub system that you see right now is accessible even without VPN, one of the few services. And sorry, I would like to walk you now how you can get started using this. So this is the view how it looks like more or less when you open this the first time. On the left side, here you have several icons. The first one is a file browser. This shows you the content of your personal home folder, where all the notebooks by default will be stored. This here is the launcher window. This you can use to start a notebook document. Before I show you this, first, a Jupyter notebook is a document. You can combine source code, so it's for programming in Python and R. It combines the outputs of that source code and additional documentation in text form. And in this system, we provide Python and R. I will come to the details later. But before I start a notebook, I will create a folder in my personal home folder, not to mess it up even more. So for this, you click on this icon here, then you can give it a name, and then it's there. If you double click it, you can enter that folder. And now, whenever I start a notebook, this is my active folder now, and everything will appear inside of that folder. In the example, I would like to start with a Python notebook. So this first few icons here are all Python notebooks, and the right ones here are for R. And all of them do the same. They create a new document. The only difference is that the programming environment that's connected to this document is different. So it can be Python, R, it can also be different Python versions, and this is what you see here, what is actually behind the different buttons. So here, what I would recommend if you want to use Python is either this, the one with the P, the Python 2.7, or the Python 3.6. When you start from scratch with something new, then I would always recommend to use the latest one. But I know that there's lots of old code there using Python 2.7 or Python 2. For R, it works basically the same, but I don't show that today. The other icons here are some system icons. You can use them. There is also a programming environment behind that, but it's not as big, and there are not so many packages installed. So now I will start a new document, clicking on this Anaconda Python 3.6 tab, and then you see in my home folder here this new file appeared, and the programming interface, or the interface of this document, is also here. First, I think it's good practice to give it another name, so maybe demo1. And you see the extension, it's an IPyNB, so it's an IPython notebook. That's the standardized format that all these Jupyter Hub systems use. In the main window, you see the box here. In this terminology, it's called a cell. And here you can type your text, your documentation, and so on. In the upper right corner, you see which programming environment is connected to this document. In this case, as I said, it's the Python 3.6. Now, traditionally, a very simple example, you just print a hello world. This is now the source code that's inside this document. You can save it here with the save button. This is also done every few seconds automatically. And if you want to execute this code statement with this environment, you just press the play button, and of course you get this hello world output. This is now Python code. So in Python, it's also quite common to add some commands. Like this. This is code that's not executed. It's just for you and for others who read this code to help them to understand it. When I executed this, a 1 appeared in between the brackets here. If you can see that, this is every cell that you execute gets a series of numbers. So when I execute this code again, of course the output doesn't change, but now it's the second cell. And this way you can start creating your program. Of course, you can also add some documentation here. So if I would press play here, of course, this would give an error because this is not Python syntax, but I can change the type of the cell from code to markdown. And when I execute it, then it becomes some nicely formatted text. The same I can do with headings, for example. Then it starts with a dash. Need to change it to markdown again, press play, and now it's a heading. This also works with second or third level, indicated by just 2 or 3 hashes. I think it goes till the 6th level or so. Again, I need to change it to markdown. And this way you can create your document. This order is not really nice. I would like to put this maybe down. Oops. This way you can arrange a nice document with the source code that you use to prepare your data together with the documentation. It's always good to save from time to time, even if it's done automatically. What you can also do now is you can share this with others, download it. You can also export it in other formats, for example, like a PDF. Takes a bit. Now it offers me to open it. It's now demo1.pdf. Now I get a nice, slowly at least, a nice PDF document with the source code, the output, and all the documentation. Let's come now to this programming environments data in the back. As you know, this is a Python 3.6 in this case. And there's really a normal Python interpreter in the background. I can just ask again the version number here. And this exclamation mark in front indicates that the system treats this statement as a shell command. So when I execute this, it really tells me it's the Python 3.6. And when you start creating programs, of course, you don't start from zero. You're using lots of libraries for plotting whatever. And in this environment, there's also quite a lot installed already. You don't need to remember these commands. I would just like to show you what's there. You can do this with the conda list command, again with the exclamation mark. And you see in this case, there's a bunch of libraries already pre-installed. However, in the beginning, I said that this environment is a shared environment. So all these environments that are already there are read-only. You can use them, but you cannot change them. And in case something here is missing, it's not possible here to install something new. However, you can create an own environment and adapt it to your personal needs. Now I would like to show you how this works. You can also do this within this Jupyter Hub interface. There's a wizard for that. You find it under Settings and Conda Packages Manager. Here again, you see the old Python environments that you cannot change, but when you click on the plus, comes a wizard and you can create a new personal one. Call it my custom env, for example, you can select for what it is. I will use Python 3 again. When I press OK, this thing is created. Takes 1 or 2 minutes. And it's important to know that this whatever you create on your own is installed again in your personal home folder that I showed in the beginning. You won't see it. It's a hidden file, but it's there in the terminal. You can see it. And then once it's set up, then you can use this this packages manager to install further package that you need. While this is installing, I will go back to the previous demo and show you how this would look like. And I switch not to the new one that's just being built right now, but I would switch to the old Python version that's already installed there. So Python 2.7. Now up here, you can see that the connected programming environment changed. But of course, the output didn't change yet because I have to run it again. I could either go now through every code cell and click the play button, but instead I will, in the run command, use the shortcut and just run all cells. So the whole thing is executed again. You also see the numbering starts with 1 again. So everything is set to 0 before, and now it shows me here that it's the Python 2.7 in this case. Again, with a very long list of libraries. In the meantime, it seems that the custom environment I just created is done. So I go back to this packages page. So it's here. You see a few things are already installed, indicated by this ticks here. Now I would like to try to connect the new environment to this notebook. Sometimes it takes a bit till it appears in every drop-down menu, but here you can see it's already there now. So I'll connect to this. I will run it again. Oops, it didn't connect. Okay, now it did. Now I'll run it again, and now you see the completely new installed one got really the latest Python version. It's 3.91 now. And the list of packages is also quite short now. So it's really the absolute necessary set of libraries that's installed. So now in this package manager and this custom environment, I can install whatever I want. So for example, like NumPy, I just click what I want here. I could also go on and select some more. When I'm done with my selection, I click this shopping cart symbol here, confirm again, and then this package and all the dependencies will be installed. That's basically what I wanted to show. Okay, it's already there. I can run it again, and you can see. So now this list is quite long, and NumPy somewhere here appears. This is what I wanted to show for this public server. And this server is a shared server, and it has quite limited resources. So if you need a bit more power to do your work, it's also possible to apply for an own machine, either for yourself or for your working group. And this you can do using our marketplace. It's under marketplace.avi.de. Then you see a catalog. Again, you need to log in there. For this, you need VPN. Then you see a catalog view with a few different machine types that you can apply for. And here also Jupyter Hub for MOSAiC appears. It's a bit strange that it's mixed between German and English. This is because some parts come from the operation system, Windows in my case, which is German, and parts comes from the system, which is English. So for many of you, this should be submit. However, it's not too many choices that you can make there. So I apply now for a known Jupyter Hub. Unfortunately, my internet is not the fastest, so this might take a little bit. And then we see this application form. We strongly suggest that you add a description here. I show you later where you can find that again. Let's call it MOSAiC demo. You should also set up the lease days number a bit. This is how long this machine that you create will exist. Maybe let's put it to a week or so. After that time, this whole machine will be completely deleted. And you can choose how much resources you need, from very small with just 2 CPU cores and 4 gigabyte RAM up to 16 cores and 32 gigabyte. So I choose a small one in this case. Again, here, this is a German button, absenden. With this, I submit this form, and I'm forwarded to the next page, the deployments page. And here you can see all the machines that you applied for. The upper one now is the one that I just applied for. So here you have a progress bar. It's now at 0%. This will take about 45 minutes till it's done. I already did that a few hours ago, and then I would like to continue with this ready-made one. And in that one, again, in the description field, I said MOSAiC demo. This is quite nice if you have, like in my case, several machines that you know for what it actually is. This one here will expire in 2 days. Of course, you can prolongate that. You click on Aktionen and then change lease, and then you can set a new date. But the main or the most important info that you can get from this point is the IP address here, under which you can access your new machine. So I will just copy it, open a new tab, and before I do that, please don't forget that, I will log out from the first one, because all machines use the same configuration files and same files in general. So it might confuse the system. So this is now the new one. It looks basically the same. Of course, I need to log in again. It's a bit slow today. And now you can see here in this address, I'm on a completely different machine, but I have the same state as before. So I have the same demo 1 notebook I last modified 4 minutes ago. It's this my custom environment that I created on the other machine, and I can just continue working here. So when a machine from the marketplace, for example, is deleted, what you set up so far, all your data is not lost. It's all on the central storage. It's just the machine that gives you access to this data is gone. One last word about where to find help and documentation. Heidi already showed it. Again, this mosaic.data.org site. Here also the documentation is linked. This should bring you to this site, and there's also a page about Jupyter Hub. Here's written down what I showed you today, and also how to apply for machines in the marketplace. And of course, if you need help, as mentioned already, there's this contact form, and then you can send us a mail, and we try to help you. That's from my side, and now I would like to pass over to David, who will give you a nice example of how you can use this with your own data.
Yeah. Share. So, hello, I hope you can hear me, and I hope you can see my screen now.
Yes.
Nice. Okay, so yeah, I was asked to prepare a little example how to access and edit and write the MOSAiC data via the Jupyter Hub. And so I prepared a little Jupyter notebook. And so when we would start from scratch, I had here already created a folder like Stefan already showed you before. And so I think we will provide you later this Jupyter notebook. And when you have this file, you can click on here and you can upload this notebook. Okay, then I open it. And yeah, so, okay. First, we want to know where our data is. So when you play through this example, okay, you can type here cd this path, and you come to raw snowpit data. And we are, for this example, we selected here the snow water equivalent, the raw data from the ground measurements. And yeah, so in this case here, I needed to install a module for Python first, but I refer to Stefan's presentation. You should really rather use this Anaconda environment or create environments and install packages there. So then I import. Sorry. Okay, so I import this pandas module. I define an input path where we have our snow water equivalent data. We read this data with this, in this case, with this pandas function, and when we print this, in this case, it's a table. We can see here. Okay, our output shows us a table with device operation IDs. We have here a parameter that is millimeter snow water equivalent, and we have here a parameter that is the snow height in centimeters related to the snow water equivalent measurement. And so what we want to do now is just cut off this stuff here. Maybe we just don't want to use it for specific calculations. So, okay, we are just interested in these two columns in this example. And okay, we extract only these two columns, and you can see, okay, we have here this millimeter and centimeter. Next step is, okay, we want to calculate the centimeter to meter, and in this cell here. And further, we have to change our column name at the top. So we rename it to, we also rename the first column, but also the second column to snow water equivalent millimeter and set in meter. And we define an output path, and that is now what you have been showed before. This projects this projects folder, and we defined here. We created this folder before for this webinar, and we defined this output path, and we write the processed table into that path as a CSV file. Okay, and to test if it has worked, we read again with also pandas from Python this file from this path and print it, and we see, okay, it has worked. Yeah, that's basically all for now. So if you're interested into work through and can test around, we will provide you this example. Yeah, I think that's so far all from my side. Okay, I don't know who's next.
Yeah, I guess it's me again. Now I'm going to show you an example how to access this data. David, could you show me again where did you put the data?
Yeah, wait. Okay, it's in this projects DMZ teams ice, and then we have O2 snow,
Right.
Snowpits webinar data.
So I have my SFTP drive. I hope you can all see that, my screen.
No, not yet.
Not yet? What? Now.
Yes.
Yeah, perfect. So I already, as I showed you before, I connected to MC with the private name MOSAiC-data, remote host MOSAiC-data.org, then my MOSAiC username and the password. Oops. This is typical live stream. So now I'm there. So then the first folder is always the home local. This is where you find yourself when you connect, and we want to have this one, and then his file was their Teams ice and snow, I guess.
Yeah, the second one. And then it is
So
webinar
this
data.
one. Yes, it's this one. So
I think I put it. Okay, maybe I made something wrong with writing. I thought I would have put it into this folder.
okay, it's okay. It's there. So this is a practical example how to connect the data. And I can also open it. Okay. So that's the data. That's the file that we just created, and we can freely access it anytime with FTP easily. At least I managed to do that. So if someone wants to say something to that, I don't know, but I guess I'm finished with this.
Yeah, thank you, Heidi, and Stefan and David for the presentation. We have also some few other experts with us from the data center who can also answer questions. If you have any questions to anything that's being presented, or problems to access the MOSAiC infrastructure, we also have an expert for that here. Feel free to ask any questions either directly or in the chat, or also via mosaic-data.org afterwards.